Shayna Lee from. Oh, that's right. We're going to get officially now we're recorded. So I'm welcomed by our speaker today, Rachel Wells, that is also a part of DataKind as well. So before we dive in, just a quick level set on who we are at DataKind. We are an organization, a nonprofit organization, where we ultimately help mission-driven organizations unlock their data science potential ethically and responsibly. We team talented volunteer experts with visionary social actors to collaboratively design innovative solutions to tough social challenges. And as I mentioned, this particular webinar is a part of a series that we have called the Nonprofit Data 101, where we ultimately help provide these engagements towards building nonprofit and social sector data science capacity. This program provides 1-hour webinars on various data science topics, followed by the option for you to opt in and participate in a free 30-minute one-on-one consultation with DataKind. And so for our webinar today, here are our learning objectives. In this hour, we're going to talk about what does it mean when we're saying terminology and definitions like ML, AI, even GenAI, and more. Learn about the basic mechanisms of how ML, otherwise known as machine learning, AI, otherwise known as artificial intelligence, work. We're going to talk about examples of how this technology is used in the social impact sector, examine the ethical considerations and challenges alongside the opportunities, explore resources that can help one get started, and be ready to talk about your specific situation or questions you have if you want to opt into our 30-minute office hours. Here's our agenda for today. As I mentioned, vocab, what's what, how does it work, examples, use cases, how to get started, as well as we'll make sure to have time for questions. So if you have any, please be sure to put that in the Q&A section in the bottom of your Zoom screen so we can track questions that come in. So without further ado, I'm going to turn it over to Rachel Wells, our speaker.
Thanks so much, Shayna. Well, let's dive right in. What is artificial intelligence? The big word people have been talking about lately. Essentially, artificial intelligence is just an umbrella term that encompasses a lot of things that are all involved in teaching a computer how to learn. It's really thought of as the replication of human intelligence, what humans do, happening in computers, and how we make intelligent machines. It includes a lot of different scientific disciplines and technologies, allowing computers to carry out tasks commonly associated with humans. So a couple examples include a search engine, checking through many, or even all possible outcomes on the web to figure out what's most relevant. And that is a big original use of artificial intelligence many years ago with the first search engines, and then chatbots and virtual assistants, and even speech recognition like Alexa or Siri can hear you. But if you're just typing into a chat and you get an auto-generated response as you're browsing an online retailer, that chatbot is also always artificial intelligence. So some simple examples. And there's tons of different ways to do this, but some of the ones we'll focus on today include machine learning, which is ML, and deep learning. And machine learning is really the most developed and the most applicable field of artificial intelligence for most organizations. So with that, what's machine learning? So there's not really a clear line between machine learning and statistics. If you think about terms like predictive analytics or statistical modeling or machine learning, these are all really referring to the same thing, which is teaching a computer how to learn through observation. The machine can learn using data sets instead of just a hard-coded rule. So an example of artificial intelligence that isn't machine learning is like an if this, then that bot, where it will just respond based on a rule, whereas machine learning means it responds based on the data, whether that's structured or unstructured. We'll talk about later. But so this learning takes advantage of the processing power of modern computers to process huge data sets and help you learn to achieve the goals that you're set out to achieve. And so machine learning really gets better as it repeats and corrects itself in its objective and in working towards a task. So there's this training stage that we start with, and this is really when the model is developed and is learning through repetitively attempting to achieve the goal over and over and over again, and correcting itself. So in summary, machine learning is that subset of artificial intelligence that allows machines to learn from the data without being explicitly programmed to do a certain thing. It teaches patterns similar to how we teach kids how to read, write, and speak. I have a baby right now, and so watching her learn to speak really reminds me of what happens with training machine learning models. So a few examples include computer vision. So when you have a picture and you see the computer is noticing that there's a face and an iris, or fingerprint recognition, or number plate recognition. Natural language processing. So a search engine can understand the question that you've entered in human language. Spam detection. So your email inbox probably auto sorts and all your spam goes into a folder that you never see. That is also machine learning. Self-driving cars, they can drive safely and follow traffic rules with machine learning. Recommendation engines. So a popular example, of course, is a streaming service like Netflix, or a shopping service like Amazon. A recommendation engine or predictive analytics to make a suggestion of what would be interesting for you involves not just your historic viewing habits and the things that you indicate are true about yourself by historically watching a certain show, you might be interested in a similar one, but also the habits of billions of people. If someone else liked this show and has similar taste to you, what else they liked might be interesting to you. Coupons for your shopping habits. If you go to the supermarket and you get this receipt with coupons on it, or seasonal or impulsive preferences that come from data that they collect at checkout from yourself and from others. Estimating energy use. So we can predict individual patterns so you can know your future electricity bill, or collective patterns for a usage of electricity or telephones or other services, and including things like how to optimize the systems that are providing electricity to us. We were just talking about my colleague is getting solar panels installed. And so they are, those utility companies are estimating energy use to make sure they're optimizing where all of these energy sources are going. And even things like predicting health outcomes to figure out what type of preventative medication we should be taking. So how do we do all of this? So how do we get started with machine learning? What does that look like? This is a really simple 3-step recipe. And the first step is to collect some data that you want the computer to learn from. So here's an example of some data, a simple scatter plot. Most of the time it's not two-dimensional, but just for explanatory purposes, the data is distributed across this graph. And then our second step is to teach the computer to find the pattern. So this orange line that I just drew is an example of what that pattern kind of looks like. We're seeing that the dots follow along this line here. And then finally, we're going to ask the computer to make a prediction based on that pattern. And so that's the step that goes beyond just statistics a little bit and takes it into machine learning, where we're applying it in applied statistical methods, essentially. You're asking the computer to find out. So if our x-axis has a data point at 5, what's the y-axis that we suspect will be in that situation? So if I really enjoy watching Paw Patrol, would I also love watching Bluey, as the example there? But we actually have added a step 0 to this machine learning recipe, because it really simplifies what we need to be doing with machine learning. But we always want to start when we're using AI and machine learning, deciding what is our goal. A big part of AI and machine learning is deciding which methodology, which model, which algorithms to use based on the goal. So here's an example, and my colleague Caroline will post a link in the chat of resource that can help with figuring out what your goal is. There's many different types of machine learning, and what you're trying to do will help you figure out which type will be most applicable to use, whether it's even even is applicable at all to use it, and why, instead of just focusing on how. I think a lot of folks, when getting started with machine learning and AI, are key on getting started with coding. How do I program? How do I implement the models? But a big part of this work is selecting the right model and making sure you know why and when to use different pieces. So we'll dive a little bit now into a few examples of what different types of machine learning look like. So machine learning is broadly categorized by supervision. And the first most common type is supervised. This is historically what has been usually used when referred to as machine learning. So an example would be, what is the probability of microloan being repaid based on financial data from past borrowers from that individual or previous instances. So just predicting that involves labeled data sets, which means that we know what the expected output is, and we have those inputs. So each data point has a corresponding label. The input and the output are provided. You know what you want to predict, and you can use that information to what we call train the model through what's basically trial and error on that labeled data set, which we call training data, so that ultimately it can be implemented on an unlabeled data set to predict those labels or the outputs based on the data inputs. So it's a little complicated, but there's three possible results when we are training the model with these data that have our inputs and outputs. It could be underfit, as in the model is too simple. It could be overfit, the model is way too complicated. And then there's the goal of being a good fit, a happy medium. But how do we know which result we're in? That's where testing the data comes in. So we have a training data set and a test data set. And the test data set allows us to score the models. And then we can go back and update the parameters based on our training data again to better figure out what would be the best fit model. You can think of it as a function approximation. So if you think about the graph in the previous example, we've got the outputs, maybe the y-axis, the inputs, the x-axis, and we're trying to get the curve that represents the true relationship between those two elements. So going back to our example, how does past behavior indicate whether someone will repay a microloan? So if we follow the data points perfectly, that would lead to overfitting, and a straight line when it really should be curved would be underfitting, and a good fit from testing and training and replicating is somewhere in between. And if the output generated by the program is wrong, it can readjust its calculations. And this process is iterative until we have a good fit on that test data set. And then ultimately, what we're trying to do is use it on unlabeled data set. So an example would be for image classification. If you have pictures with eyes and you're trying to find all the eyes, you would have some images that are labeled, here's the eye, here's the eye, here's the eye, and then some that aren't yet. And that's when you would be implementing it once you've trained it on the labeled data sets. Or weather prediction, learning to predict weather data using historical data. Inputs for the training data could include humidity, wind speed, temperature, and then that output is chance of rain. So we know historically that we want to predict in the future the chance of rain. So that brings us to our next category, unsupervised. So this is when machine learning is using data sets with no specific structure, which is known as unlabeled data set. We don't know the result of the thing that we want to predict. We still know what our question is, but we don't know, we don't have labels for our goal. And we're trying to find patterns in the data. We're looking for structure. Going back to the child analogy, this is like a child learning language. All they hear is adults talking, and they are just trying to figure out what it all means, right? And so in practice, this is typically done by finding automatic ways to convert an unlabeled data set into a labeled set. So this is called self-supervised learning. And when a training algorithm uses self-supervised learning, it will classify itself automatically. So one example of this is an e-commerce website or your Facebook newsfeed if you're on social media. The network doesn't learn from a training data set. There's no data set that says, Rachel likes this post, Rachel likes this post. Instead, it's learning based on the historic data and being updated. based on what the algorithm has learned. Another example is next word prediction. So if you are typing on your phone, sometimes your phone might suggest what word you might want to say next. Like, I think that's great, for example. And so that would be able to predict from sequences of text what word might follow based on your patterns in the past. So impressive applications of self-supervised learning are some of these generative AI things we've been seeing recently, like GPT-2 and 3 and DALL-E for images. And this is the most common type of unsupervised learning, but there's also reinforcement learning, which is essentially trial and error. The data source is not a fixed data set in reinforcement learning. Rather, the data is an environment where the AI can take in actions and receive observations, and then get a reward based on their actions. And an example of this is a video game, or really any board game. The AI can play the game, can take an action and see if they get a score, or see what the other player does if they're playing chess. And these actions, the call and response, reinforce the behavior, leading to higher rewards and reducing the behavior that leads to lower rewards. And so since actions can have long-term consequences, like think about chess where you make a move and turns later, it was the move that was the thing that made the game end a certain way. The key difficulty in reinforcement learning is determining what actions are responsible for which reward when they're not sequential. And so this means there's a balance between exploring that uncharted territory and exploiting current knowledge in order for the machine to learn that optimal behavior. And so this really differs from supervised learning in that the labeled input and output pairs are just not presented. It's learning and figuring out what connects to what. It's used commonly in self-driving cars as a big one, operations research and optimization, games, robotics are other use cases of reinforcement learning. So some common ML tasks, we've just talked about some of these, but this is another way to think about it, is regression. Essentially, we're predicting a continuous value attribute associated with an object. For example, the likelihood of repaying a loan, predicting housing prices, ranking an image based on its aesthetic appeal. Then a classification problem is identifying what category the object belongs to. So like for medical imaging, identifying what something is, or trying to predict, like, does this image have a car in it, or does it have my dog in it, or does it have a human face in it? So this is the discrete categories piece where we're predicting that. Clustering is automatically grouping similar objects in a set. So an example is customer segmentation for targeted ads. If you've ever gotten like a mailer in the mail or an email that seems to think you behave a certain way, like other people who behave this way, like airline points, or targeted ad for a discount of a type of product you might be interested in. This probably means you've been clustered into a group with people who have similar preferences as you. You've all been sent the same marketing campaign because of that cluster of how you've been identified. And then reinforcement learning, we just talked about this. So this is trying to use those uncertain environments for training the AI. And so the example being a driverless car is a key example here. Okay, so our last big term here is deep learning. This is a subset of machine learning, and it's based on artificial neural networks, which is even more powerful than classic statistical methods. When we think about the timeline here, the history of all these words, it started with AI, and then we went to machine learning with the data, and then we've gone to deep learning. But that said, a lot of the core algorithms, a lot of the stats behind deep learning have actually been around for 50 years. And it's really only recently that computers have had the capacity to run these systems because of the compute power that's become available in the recent dramatic increases. So computers can do a lot more and be a lot more impressive and complex, as we're all seeing with generative AI, for example. And so that's why this is the cutting edge area recently. So what does it mean for its neural networks? That's what distinguishes machine learning. Neural networks closely mirror the workings of the human brain. So there's complex inputs and outputs, and they can output images, behavior, etc. And it's really a new paradigm with all the different layers and complexities of inputs and output layers. So it utilizes these artificial neural networks, which can handle billions of inputs of parameters without excessive overfitting. Remember earlier we talked about how if we're too closely modeling the training data, we overfit our model, and these billions and billions of data sets would typically lead to that. But with neural networks, you can solve for some of that overfitting. And so these multiple layers of interconnected nodes allow the neural networks to learn from data through training. And this can be used in unsupervised, supervised, reinforcement learning. So one example would be in reinforcement learning with a neural network, the approximators can be referred to as deep reinforcement learning. So deep is that technical term that means there are multiple layers in the neural network. So a shallow network has one hidden layer and a deep network has more than one, essentially is what's going on behind the scenes there. But as we get deep, so we have multiple layers, each layer extracts and refines the features automatically. These multiple deep hidden layers allow the features to have hierarchy, which takes us from simple features. So for an image, you might just think pixels, right? A couple dots of a certain color or something can recombine from one layer to the next to form more complex features like a line and ultimately an image. And so that's how neural networks can develop images. So neural networks with many, many layers, like something that develops images, like DALL-E, for example, pass that input data, all the features through mathematical operations and are very computationally intense. So large language models, the base of generative AI, use deep learning techniques in order to generate new content. So to summarize, we talked about a lot here, but all in all, the three things to know is that AI is that technique or system that allows the computer to mimic human behavior, whether it's feeling, thinking, acting, adapting. We're thinking like humans, and it makes computers do intelligent things, language, vision, etc. And then within artificial intelligence, we have machine learning, which is the technique used to provide AI with the capacity to learn using data and without using the explicit programming. So you don't know if this, then that. And then deep learning are those machine learning algorithms characterized for complex neural networks with those multiple layers to do really deep machine learning. So AI progress today requires three elements, this AI triad: compute, computing power, algorithms, the models, and of course the data. So in order to successfully implement and scale AI-driven solutions, we really need sound technical infrastructure in all three of these areas. And so what might be new, you're probably familiar with you need data and you need algorithms. So what might be new is that compute piece. And it's a main constraint for a lot of individuals trying to do something technically complex. High capacity resources to handle heavy computing workloads and network infrastructure that's high bandwidth. This can be really difficult for folks in low resourced communities in places around the world that don't have that access. The commute can be a really big barrier to using AI. So that's something to be really mindful of, especially when we're thinking about equity. And algorithms, so when we've been talking about ML and statistical models, we've already covered algorithms, so I won't spend more time here, but I do want to note from an equity standpoint that there are a lot of reusable models and tools now that can be used on new data sets and computed for new use cases. But if we don't have the compute power and we don't have the data, then they're not able to be used in that way. And so when we think about data, the foundation models that are used for generative AI use all types of data, but you might just be using individual data from your organization for your use case. And for specific AI solutions to be useful and responsible, for them to be trustworthy, inclusive, transparent, there's a large amount of local data needed that is adapted to the local context and reflects the unique social realities. And so data availability in regions with low data infrastructure or capacity is a real barrier as well to using machine learning and AI. So really, if there's not data on something or of someone, then the system won't learn it. And so representation and equity are really key things to be thinking about for AI progress in the data space. And so overall, the cost of implementing AI really can come from this need for large amounts of data or compute resources, and can be a big barrier for constrained social impact organizations. So there's a link just shared in the chat that kind of talks about this digital divide and some of the nuances to think about in the constraints as you're developing these solutions and you're planning to use AI and machine learning in your situation. But I want to take it further. These are not the only things needed for implementing AI and data science and machine learning. So what is needed to implement AI and machine learning? We have been working for 11 years now and have built and execute so many data projects, and we've found that these 6 components are really necessary for success. And you'll see that data is one of them. Data scientists is another one, but that's only 2 parts. And that includes the data, and the algorithms can come from data scientists who know what algorithm to choose. We also look to have clearly defined problem statements that represent actionable pain points. And those come from discussions with subject matter experts on the topics we're addressing and social actors on the ground working on addressing these problems. Like we just talked about, resource constraints for compute power and trailblazing funders are key to help diffuse that risk and platform and scale for that. We also, as we identify and build and execute projects with that goal of global good, we use that available data and the teams of expert data scientists the DataKind brings, but we also need to identify these other key components to mitigate risks that prevent us from achieving the goals, and make sure that we're thinking carefully about ethics and risk mitigation in all of these areas as we pursue data science and AI. But what about generative AI? It's been referenced briefly, but not quite defined. So we're not going to dive deeply into generative AI in the next half hour because my colleague Matt did a fantastic webinar in February. We'll put the link in the chat, and I encourage you to check it out if you weren't there. It covers opportunities, risks, what we are and are not using generative AI for, and all of that. But essentially, generative AI creates new content. It uses a new type of neural network architecture that can generate text called a transformer. When we think about those categories I shared earlier, it fits under that self-supervised category where it's unsupervised, but it creates its own labels, uses billions of parameters, and some examples are DALL-E, ChatGPT, Bard, Bing, and it uses language models, which really move us towards more capability of the models, towards general intelligence instead of just specific tasks. So that's things like writing poetry or writing code, and learning from examples and taking action. So this increased capability can be more powerful and requires a lot more careful consideration of risks. So we've covered everything on what is machine learning, artificial intelligence, all the different types, and how to think about those things. But we'll go into now some examples of how it's being used in the social sector. Our first example is with Vision Zero, which is a global movement centered on the idea that no pedestrian or bicyclist death by motor vehicle is accepted. So starting with the question, how do we reduce traffic deaths? DataKind needed to bring together a consortium of stakeholders, like we talked about, one of the 6 components in our 3 partner cities. And ultimately, the team built a machine learning model to predict our output of crash likelihood using over 100 features as our inputs. And we primarily used open data in order to do this. And so this helped understand how safe or dangerous an intersection is and if it would need intervention. And we also were able to use the models to simulate the effects of different policy and engineering interventions. So when we think about the features in the model, some of the most important features for crash prediction included things like traffic volume estimate, signal count, raised median, number of intersecting streets, and the count of bus lines. And so we were able to take this work forward with Open Data Nation. Another example of our work is a project that starts with a sobering fact. 36% of the global population lacks access to a toilet, contributing to health and environmental problems, which is a particularly important issue in cholera, where there were in Haiti, where there were nearly 14,000 cases of cholera in 2017. And our partner organization, Soil, is a nonprofit working on dignified sanitation in Haiti, and they provided more than 1,000 households with container-based sanitation toilets, and they safely transform all of that collected waste into agricultural grade compost, combating huge global problem of lack of access to toilet and sanitation facilities. Now, what does that have to do with data science and AI, right? So Soil needed a solution to help manage the costs and the logistics of transportation and effectively plan their routes, because there was really limited capacity with their three-wheelers and their small trucks trying to transport this compost. And so DataKind created a solution that leveraged OpenStreetMap and Google OR tools to make an easy-to-use optimization tool, which outputs text and map for optimized routes for those drivers that could be referenced even places where there's no mobile or network availability. And so Soil used this solution to cut down trips by 13%, which was a huge resource savings for the organization. And they used it to onboard new drivers as they scale their services and easily reassign existing drivers to new areas. And so due to the complexity of those logistics and optimization in low resource settings, which comes from things like vehicle capacity, restrictions, long distances, road quality, fuel availability, poor connectivity, data systems, all of that. So many frontline delivery organizations face this challenge. So DataKind has worked with several other organizations to create route optimization solutions for their context and needs, including Riders for Health in Lesotho, Sanoma in Peru, and Sanergy in Kenya. And so with Sanergy, they wanted to serve more customers, but needed to understand how to best expand while reducing operational costs, which sounds like a data science problem, right? So we worked with them to replicate the route optimization solution and create reusable scripts for training, like we talked about, training as the first part of model development, a forecasting model to predict future volume needs based on historic data. These are inputs, growth projections, more inputs, field studies at sample locations, and more. So you can see how that is an example of a machine learning case as well. Next, we worked with the American Red Cross in 2014. Starting in 2014, DataKind DC partnered on their nationwide home fire campaign, and we brought together tons of data from previous fire incidences, census variables, and more to estimate which areas were likely to have high fire risks and a low likelihood of working smoke alarms installed in the house. But the question remained of what was Red Cross actually going to do with this machine learning tool? And it turned out the answer was quite a lot. And since the launch of the campaign, the Red Cross, in partnership with local fire departments, conducted nearly 900,000 home fire safety visits and installed more than 2.1 million smoke alarms in high-risk homes across the country, which ultimately connected to documenting 794 lives saved. So Red Cross staff, volunteers, and partners across the country have used the fire risk map created by DataKind to leverage smoke alarms in their neighborhoods and in the communities that need them the most. So DataKind is working again with American Red Cross in these last couple of years on a follow-up project to refine that other underlying model. We talked about how the model is determined by the training data. So with new data available, relevant and current data, we're updating those models, including using data on smoke alarm installation and tests. Another example starts with a problem of frontline health teams carrying huge logbooks for data entry, which can weigh 5 or more pounds to record healthcare interactions. And it can take weeks or months for those records to be digitalized and the data acted on. And so Data partnered with Riders for Health, an international NGO providing essential frontline services in completing paper-based data capture for Ministry of Health forms. And it was able to take about 80 days worth of previous efforts to go from writing down the data record to digitalizing it and analyzing it, to allow that to happen in just minutes with an optimal character recognition tool. Another example of machine learning and AI in the social sector is thinking about housing. So landlords in the US file around 3.6 million evictions each year, but we still know very little about the prevalence, causes, and consequences of housing loss. So in order to find out how many people are going to need housing support, where housing loss is occurring in communities, who is most impacted, we are analyzing eviction data to support housing leaders. So DataKind developed a tool called the Foreclosure and Eviction Analysis Tool, FEAT for short, closing that eviction analysis gap. And it has been, in partnership with New America, developed to ingest that local eviction and foreclosure data for analysis, cleaning, standardizing, geocoding it, all of the behind the scenes work needed to get to machine learning, in order to analyze where evictions happen, when they happen using time series, and who is at greatest risk. So we can calculate risk using machine learning for with a combination of socioeconomic indicators and housing loss historic data. Okay, one more example. The Moulton Niguel Water District provides water, recycled water, and wastewater services to about 170,000 people in many cities in Southern California, where there have been substantial amounts of droughts recently, thanks to global warming. And so, like many areas in the region, they didn't have access to local water supplies and have this huge expense of importing drinking water. And so with the worst droughts in the past 500 years, they worked with DataKind to more precisely and accurately forecast water demand using machine learning so they can improve pricing, expand conservation programs, and implement initiatives to increase the efficiency of water transportation throughout its network. Hugely important. And so diving into the data, which included 12 years of water usage data from the district, weather data, and census data on household characteristics, we forecasted demand for irrigation customers using high volumes of recycled water. And if they could more effectively manage and anticipate those peak irrigation water demand moments, they could avoid having to import expensive portable water as a supplement. And so with several months of analysis, we've been able to predict recycled water demand at the microzone level. And this blue line in the graph shown here is that forecasted demand with the confidence band that you can see. And so if it's at a risk of reaching or exceeding the maximum supply estimate, that red line at the top, this signals a warning to the analyst so that they can really predict that anticipated demand and manage it in advance. So this allows them to better manage water resources. Okay, but what about generative AI? I know this keeps coming up and everyone's got questions about it. So how is it being used? DataKind has already been working on generative AI projects for the last 10 months now. But if you were wanting to get started with generative AI, the first thing I would say is think about it as a good way to augment your human skills with just a first version of creating content drafts. So drafts of proposals, reports, emails for fundraising or other reasons, marketing campaigns, program plans, just generating ideas and approaches to evaluate the effectiveness of different programs and things you're working on. Things like aggregating meeting notes and making a list of action items are all really useful ways to just kind of save you a little time and effort with AI. And you can generate on demand specific royalty-free images for public use with something with generative AI. And even generating code that would be able to be used for creating a data visualization that you might be looking for with specific colors. And instead of taking the time to figure out exactly how to code that, you could ask generative AI to come up with the code for you and apply it to your data. But those are just some ideas of getting started with content drafts. Want to emphasize here that we're just talking about making a version one, something to iterate on, but the human element is absolutely essential in anything that you develop. But I'll go into now a couple concepts of ongoing work that DataKind is doing with Save the Children to leverage generative AI in the humanitarian sector. But please look out for more coming soon from DataKind. So for example, DataKind is predicting metadata to help fill data gaps for humanitarian response providers. DataKind's also retrieving information quickly to address high-risk disasters. And we're parsing unstructured data for use by Save the Children. There'll be links in the chat for blog posts on the technical side of things for how to do all those things, and more coming soon on what that might look like. So our last section of our agenda before we get into questions is getting started. You might be wondering, okay, what should I do first if I want to use AI and machine learning? So what should you do? The first piece I think is essential is to build your foundations with data strategy and values. Before you start creating content with generative AI, before you start using machine learning models for anything, really take time to think about your values and how that will impact your work, and learn more about data strategy and values so that that can be implemented. In the social sector, this is essential in all of our work, but it's really important with data because there are so many risks and opportunities for things to go wrong if you don't take the time to carefully evaluate your value integration here. So then once you've got strategy and values in place as your foundation, you'll need data infrastructure. So thinking about responsible data capture and integrating it into seamless data flow so that you have data to actually use for machine learning is a really good next piece of that foundation to move towards use of machine learning and AI. And then finally, another piece is to use tools developed by others or integrated into your existing systems. There's a lot of resources like ChatGPT that anyone can use, or AutoML, which is a way to identify what method or process would be best for using machine learning if you're not a machine learning expert. And so it really accelerates machine learning use and is a way to make it a little more accessible to folks. So there are tools that exist that can help you get started in this space without having to know everything. So use those existing tools. And so we started with the foundation of values and ethics. So I want to make sure that we talk about what that means. There's tons and tons of resources to level up on this. We have 16 more minutes. There's no way we're going to cover everything. So I've added some links here and they'll be in the chat as well. But a few places to start is just to think about representation and diversity in your team. Diverse teams lead to more incorporation of different pieces and perspectives. Think about equity in your data collection practices. If you haven't done any data audits where you look and ask questions about inclusion and other things of your data, that's a big way to really think about ethics and values in machine learning. Cost benefit analysis alongside really checking what your assumptions are and what risks might come up as you're scoping and defining your project. So all of this is before you even get started with doing anything. But as you're getting started as well, use the user research and careful review from key stakeholders throughout your work and before your work. Model transparency can be a really big part of ensuring your values and equity is incorporated into your machine learning work. Test for bias, ethical red teaming with community feedback. And there's lots of different test methods to really help mitigate bias as you're doing machine learning. And of course, continuously monitor and assess. They're never really done. We don't have like a checklist to ethical success. It needs constant review. And open resources can be really helpful too, to get more feedback from people and utilizing things that are open as well as opening what you are able to. But do not take this list as, oh, I've got all these things done. Ethics and values are check. The use resources, a few listed here as well as others. Project Evident has an AI 101 that really focuses on bias and equity. The Data Values Project is an awesome blog and a community space for really seeing a lot of examples of what this looks like in practice in the social sector. I love We All Counts data equity training. It's a really good way to learn the foundations here. And Montreal's AI Ethics Institute is my favorite newsletter for AI ethics literacy that really includes this accessible, deep content for the latest on AI ethics. And you can also learn about DataKind's practices. So we implement a lot of different processes and practices for including ethics in our AI project design. And so feel free to review that as well at a high level on our blog. So I want to make sure to briefly share a few questions that you could keep in mind while you're brainstorming and thinking about values in algorithms. And so this includes things like what types of harm can be anticipated from your methods? Does the model provide allocation of a resource? Could it propagate harmful stereotypes, beliefs, or unjust social or political dynamics? I won't read this whole list, but I want everyone to just think about some of the different discussion questions and ways to evaluate what could happen if things are misinterpreted or if things are not understandable, and what that outcome is and what unintended consequences could happen for certain groups in using algorithms. And then we've talked a lot about how algorithms are one part of machine learning, but there's also data and compute, right? And so when we're thinking about data, there's even more questions like who is missing? What variables are missing from your data that might help you identify who is missing? Is there historical context to check for underrepresentation? Are there biases in the sample selection or variables? Are there problematic variables that shouldn't be included in the model? Are you unintentionally using historic proxies? And more questions in that space. And even more to think about is risk, like who will be using it, who can change it, who will it affect, what's the worst thing that could happen, both if we fail and if we succeed. Just because you can use machine learning, should you? Are there other ways to get the results you're looking for? What trade-offs are you going to make? Are there changes in power structures that are transparent, just, and reversible if the model is discovered to cause harm or potentially cause harm in some way? Lots and lots of questions to think about in the ethics space. So that kind of gives you a brief overview of that data strategy and values to build your data foundation. But what about getting your data infrastructure together and then using those tools developed by others integrated into your existing systems? So once you've thought about values, a good place to start is software that you're already using that might already have AI embedded into it. Lots of examples of that. Right now we're on Zoom, and Zoom can automatically summarize meetings for you now. Salesforce is a really popular tool for nonprofits, and they have tons of ways AI is used to optimize their reporting systems. Google's Bard is big if you're a Google user for Gmail, YouTube, documents, it's everywhere. And Microsoft Bing, pretty similarly across their products. If you're in coding, GitHub Copilot can help auto-generate code. Social media platforms have come up a couple times, but AI is all over social media. And then alphabetically, we've got Adobe, Airtable, Amazon, Asana, and probably most tools you use in some capacity. So it's worth looking into the tools you use the most to really identify where and how they're using AI and whether it's value aligned for you and whether it's something you should be adopting based on your values and strategy. So we'll close with a few favorite resources. These will also be in the chat for learning AI and machine learning. These came from DataKind's community. I'll start by saying if you're brand new to this space, there's tons of online courses to go through the basics. And then for nonprofits specifically, data.org's resource library has a ton of different resources on this space and can be a good place to look for a lot of different things. There's an intro article focused on government use. The AI divide comment I made earlier, I've got that resource here. There's tons of case studies on DataKind's blog and all over the place, like in the data values blog I mentioned earlier. And then the rest of these, Google's guide on using AI for social good is is interesting as well. And then the State of the AI report and Towards Data Science on Medium are good for once you've got a sense of what's happening with the AI and machine learning, and you want to be up to date and learn the latest techniques. And DataKind's playbook has some of the process pieces around using AI and data science in the social sector. But I will caveat that it's not a resource for actually learning machine learning. Okay, the last thing I want to share with you before we go into questions is that we have a new program that will also help if you're just getting started with AI and machine learning, in which we're going to support organizations, people working at social impact organizations, in discussing with one another their AI challenges. So we know that social impact organizations and nonprofits have been under enormous pressure to develop capacity to use AI in everything they're doing. And so because of the complex nature of needing to be risk averse to protect vulnerable populations, but not wanting to miss out on greater opportunities or not wanting to make mistakes from rushing into using new technologies, there's so much to learn right now, and we're all learning together. So we are going to have a cohort-based series of conversations for folks to engage in peer-to-peer knowledge sharing with one another, alongside some data strategy support. So there'll be a link in the chat to learn more about this program. We're really excited to focus on equitable and accountable generative AI in January 2024. And so please express your interest in the forum. The deadline's November 22nd, and I look forward to chatting with you then as part of that program. And with that, we will go into questions. So I'll pass it back to Shayna to get us started.
Thanks so much, Rachel. And if you have questions, please put them in the Q&A section so we can track. We'll get to as many as we can. One popular question that's come up is, will we share the recording and the slides? We will, which will have many of those links embedded. One question that came up related to ethical considerations and also equity, Rachel, that you touched on. So you may re-emphasize this point. How do people make sure their data sets are diverse and reflective of historically marginalized communities?
Yeah, that's such a good question. There's so many different strategies here, and so I won't be able to comprehensively answer this, but there are a lot of resources to help you out. And I'll start, if you've never done anything in this space before, I'll re-emphasize the We All Count Equity, data equity training has a lot of really good tools for this. But essentially, if we're thinking about reflecting historically marginalized communities, if you have demographics in your data sets, which you would not use for actually developing a model because you don't want to build something that's based on those demographics, you could use them to compare your data set to the communities you're hoping to reach. So for example, if you're working on like gender inclusion and you know that in the town you're working in, you have like 49% men, 49% women, 2% other, then you look at your data set and you have like 60% men, you see that imbalance, right? So you're looking to compare your data set to the communities that you're looking to impact as one starting point.
And kind of related as well, is there a way to quantify bias?
Oh my goodness, there's not one way to quantify bias, no. There's a lot that you can do to evaluate bias, and there are a lot. Bias also has tons and tons of definitions. So there's bias from a technical perspective when we're looking at statistical bias, and then there's also like bias in our society, and those things overlap and intersect, but are not exactly equal. And so when we're thinking about minimizing statistical bias, there are technical methods for that. You can, look that up, and like, as you're learning more about machine learning, that will be something that courses you take will cover. But as far as like integrating it with your value of minimizing bias, potentially, there's a lot more to that. And like the example we just talked about of comparing the community, your data set to the community that you're hoping to impact. That's one of many, many steps you can take. Another thing that can help is testing how your model performs on different communities, so that you can see if there are biases in the model. But those are just a couple examples. Lots more that you can dive into with more time.
Great. I think we have time for one or two more questions. There was a question around what's the best way to cite generated research content?
Honestly, I don't know if I have the answer on that. Please feel free to apply for our generative AI learning circle if you're asking questions like that. That's the type of thing that we'll definitely uncover. What I have so far done is just clearly document when you're using it and how and what it created. As far as like from an academic perspective, I'm sure there are academics who can better answer that question, so I would defer to someone else. But I think transparency is just the most important thing in all situations. If you used any generated content, just have it somewhere documented, exactly what you used it for and how.
Great.
For now.
And then one other question that I think we have time to get to that we can answer quickly. There was a question around, are there regulation or protocols to minimize risk around privacy issues?
Yes, there are a lot. I mean, you've got GDPR if you're familiar with that. But everywhere, I have no idea where you lived. Person who asked this question. And so your or what industry you're in too. Industries have their own regulations and protocols too. So it really varies depending on where you're working. I see you've listed an example here, spam where public shared their personal information. Yeah, so that's the kind of thing that that it's very nuanced, but it's very case by case, I guess, is the best thing I can say. But if the goal is to protect vulnerable populations who fear digital platform, right? Big pieces of that include transparency, include data protection and privacy, really strong data security mechanisms. There are a lot of tools and resources to help with that and mitigate risk. But we don't have time to get into that in detail, but maybe that will be an upcoming topic for us in these series.
Yes. So speaking of, in the last few minutes, recognizing there are so many great questions. Well, if you have those questions, sign up for our office hours. After this webinar, going on to the next slide, we will provide an email. We'll actually provide an email of the link, the recordings, and how you can sign up for office hours, which will give you an opportunity to consult with us for 30 minutes. So please feel free to take advantage of that. There were also some great questions around, how to get my nonprofit started in ML, learning about it. Well, one, you can share this webinar as an option, but also going into the next slide, this is one of many series that we have offered. So we have a playlist on YouTube available that talks about different topics. Governance, for example. We do have one on generative AI as well. So be sure to check out our playlist. We'll make sure to share those links as well via this slide. And then we did put into our poll here, feel free to respond. How has this event deepened your understanding of ML AI? We got lots of questions around how to stay involved. We put this link in the chat several times. We have a monthly newsletter that goes out. So if you want to hear about volunteer events, the types of projects that we're working on, where we need volunteers, that is probably the best way that you want to start with us, because we send that newsletter out via email each month. And then finally, actually, I think that is it with the time remaining. We're right at 1 o'clock. So last keynotes, we will send out the slides, the recording, which will have all of these links hyper embedded, including how you can sign up for our office hours. So thanks so much for joining us.